Hello, today we will focus on expanding the binomials using the binomial theorem. Let's look at the binomial theorem. For any positive integer n, a plus b the whole quantity to the n equals n choose 0, a to the n, plus n choose 1, a to n minus 1, b, plus n choose 2, a to n minus 2, b square, plus etc. plus n chosen b to the n. Let's look at each term. And when you look at the first term like a in this expansion, the powers of a are in descending order, starting with a to the n, and powers of b are in ascending order, starting with b to the 0. We know that b to the 0 is 1, so it is not shown in the first term. And also in each term, the sum of the powers on a and b is equal to n. In all these terms, you can see that the sum of the powers on a and b is equal to n. That is the exponent of this expansion a plus b the whole quantity to the n. And let's look at the formula for the binomial coefficient. N choose r equals n factorial divided by r factorial times n minus r factorial, where n greater than or equal to r. So let's expand a binomial using the binomial theorem. So use the binomial theorem to expand the binomial 2x minus y, the whole quantity to the 5th power. So we have already seen the binomial theorem. And let's look at our question 2x minus y, the whole quantity to the 5th power. So we can rewrite this binomial as 2x plus negative y, the whole quantity to 5. And we can compare this term with our binomial theorem. And you can see that instead of a, we have 2x. And instead of b, we have negative y. And n is 5. And we have already seen that the powers of the first term, like 2x in this expansion, are in descending order, starting with 2x the whole quantity to the 5th power, and also the powers of the second term, negative y, are in ascending order, starting with negative y to the 0. Negative y to the 0 is 1, so it is not shown here, okay, because it is 1. So 1 times any quantity is the same quantity, okay. So let's use this binomial theorem to expand this binomial 2x plus negative y, the whole quantity to 5. So here we can see that n is 5. So n choose 0, 5 choose 0. Instead of a, we have 2x, 2x the whole quantity to 5, plus then 5 choose 1, 2x the whole quantity to the 4th power, then times negative y to the first power. And you can see in all these terms, the powers on 2x and negative y, the sum of those powers is always equal to 5. Then the third term is 5 choose 2x, the whole quantity to 3 times negative y, the whole quantity squared, plus 5 choose 3, 2x, the whole quantity squared, times negative y, the whole quantity cubed, plus 5 choose 4, then 2x times negative y to the 4, plus 5 choose 5, negative y to the fifth power. Now we have to evaluate each term. So you remember the formula for the binomial coefficient, that is n choose r equals n factorial divided by r factorial times n minus r factorial. So by using this formula, we can write 5 choose 0 as 5 factorial divided by, instead of r, we have 0 factorial times n minus r factorial. So n is 5 and r is 0, 5 minus 0 factorial times 2x, the whole quantity to the fifth power, plus 5 choose 1. We can write the binomial coefficient as 5 factorial divided by 1 factorial times 5 minus 1 factorial. Then the terms are times 2x, the whole quantity to the fourth power, times negative y, plus 5 choose 2. We can write it as 5 factorial divided by 2 factorial times 5 minus 2 factorial. Then this whole quantity times 2x, the whole quantity cubed, negative y, the whole quantity squared, plus 5 factorial divided by 3 factorial times 5 minus 3 factorial times 2x, the whole quantity squared, times negative y, the whole quantity cubed. And instead of 5 choose 4, we can use the binomial coefficient to rewrite this. So 5 factorial divided by 4 factorial times 5 minus 4 factorial. Then this whole coefficient times 2x times negative y, the whole quantity to the fourth power, plus the last term is 5 choose 5. That is 5 factorial divided by 5 factorial times 5 minus 5 factorial times negative y, the whole quantity to the fifth power. Then we can subtract each of these expressions and we can rewrite this as, again, this as 5 factorial over 0 factorial times 5 factorial. Then we can expand this expression 2x, the whole quantity to the fifth power is 32 x to the fifth. That is 2 to the fifth is 32. Then we can apply the exponent to the x, so x to the fifth. Then the second term is 5 factorial over 1 factorial times 4 factorial. Then 2x, the whole quantity to the fourth power is 16x to the 4. Then we have negative y here. And the third term, 5 factorial over 2 factorial times 3 factorial. 2x, the whole quantity to the third power is 8x cubed. Then negative y, the whole quantity square is positive y square. And when you get into this term, it is 5 factorial over 3 factorial times 2 factorial. Then you can see that 2x, the whole quantity squared is 4x squared. Then negative y, the whole quantity cubed is negative y cubed. Then this term becomes 5 factorial over 4 factorial times 1 factorial. 2x times negative y to the 4 is y to the 4, positive y to the 4. Negative y, the whole quantity to the 4th power is positive y to the 4. And the last term is 5 factorial over 5 factorial times 5 minus 5 factorial is 0 factorial. Negative y, the whole quantity to the 5th power is negative y to the 5th. Now you remember the definition for the factorial notation. That is n factorial equals n times n minus 1 times, etc. times 3 times 2 times 1, or in other words, we can say that n factorial equals product of all positive integers less than or equal to n. So let's evaluate each binomial coefficient. So let's evaluate this. So you can see that for the first term, these two terms like 5 factorial cancel with this 5 factorial. So you have 1 over 0 factorial, that is 0 factorial is 1. So this term becomes, the first term becomes 32x to the 5th. Then let's look at the second term. The binomial coefficient is 5 factorial over 1 factorial times 4 factorial. In order to simplify this, we can write 5 factorial as 5 times 4 factorial divided by 4 factorial. So these two terms will cancel each other. So we have 5 times 16x to the 4 times negative 1. And look at the third term. So 5 factorial over 2 factorial times 3 factorial. We can write 5 factorial as 5 times 4 times 3 factorial. Then we have 2 factorial as 2 times 1. Then here we have 3 factorial. So 3 factorial will cancel each other. And then we can simplify this. So this becomes 10, 5 times 2. Then we have the terms 8x cubed times y squared. And let's evaluate this one. The fourth term, 5 factorial divided by 3 factorial times 2 factorial. So we can write 5 factorial as 5 times 4 times 3 factorial. And then the 3 factorial in the numerator and denominator will cancel each other. Then we have 5 times 4 in the numerator. Then 2 factorial is 2 times 1. Again, you can simplify these two terms. So you will get 2. So 5 times 2, 10 times 4x squared times negative y cubed. Then look at this term. So this is 5 factorial over 4 factorial times 1 factorial. So you can write 5 factorial as 5 times 4 factorial, and 4 factorial in the numerator and denominator will cancel each other. So you can see we have only, after canceling these 4 factorials from the numerator and denominator, you have 5 in the numerator and 1 factorial in the denominator times 2x times y to the 4 plus the last term 5 factorial in the numerator and denominator will cancel each other. We have 0 factorial in the denominator. This is 1. And this term is negative y to the 5th. Okay. So here it is, sorry, this is negative y to the 5th. Negative y, the whole quantity to the 5th is negative y to the 5th. So when we evaluate each term, then you can see that the first term is 32x to the fifth. Then 5 times 16 x to the 4 times negative y is negative 80 x to the 4y, plus when we multiply these terms together, you will get 80x cubed y square. Then this term, the sign of this term is negative because this is negative y cubed. So negative 40 x to the second y cubed. And when we multiply these terms together, you will get 10x y to the 4. And the last term is negative y to the fifth. So these are the terms in the expansion of 2x plus negative y, the whole quantity to the fifth. So you can see that there are 6 terms in this expansion. Hope you got it.